Hello and welcome to the unit on volume. Today we're going to look at the volume of circles, spheres, and cones. To begin with, I just kind of wanted to review a few things about circles. And if you recall, the area of a circle is pi r squared, and that can be found right here. And r is going to be the radius of a circle. So as a review, the radius is half the distance across, which is what we have here. So this would be our radius. And when I look at this circle, this is what we call the diameter. So this here is a diameter. And the diameter just goes the whole way across. It's the whole distance across that circle. And diameter is equal to 2r, or we can see that the radius is equal to 1/2 the diameter. So either one of these you may have to use at any given point in time depending on the information that we're given. So when we go to find the volume of a cylinder is essentially a circle that has been extruded or drug in a certain direction. So if you notice on this cylinder right here, we have a base that is a circle, and it's been kind of stretched or extruded a certain height, and in this case it's 8 kilometers. So the volume of this cylinder can be found by finding the area of the base, which is denoted here with a B. So that's our pi r squared, and we're going to multiply it then by the height. Now notice I have two different situations here. On this image, I was just given the radius. As to this image over here, I was given the diameter. So when you find the area of the bases, you do have to take into consideration which number you are given. So when we look at our first example here, we're going to find the volume of each figure to the nearest hundredth. Okay, so I notice right away that I'm given my radius, so 7 feet is really my radius, and the volume of this cylinder is equal to BH. Well, if you recall, B is really equal to the area of the circle, and this is pi r squared. So when I type all of this in, the volume of this cylinder is going to be pi, which I'll just type in off my calculator, r, which is given to me right here. So r is going to be 7, and I have to square that, and then I'm going to multiply it by my h, which would be this 12. The units on volume, don't forget, are cubic. So if I simplify this, I end up with pi times 49 times 12, or 588 pi. And if I multiply that out, this gives me something approximately equal to 1,847.26. My units were feet, and this will be cubed. So this right here is my final answer. Now for the other cylinder, again, I'm going to use the V equals BH. So now when I start plugging everything in, I have V equals, I have pi times my R value. Well, if you notice, I was given my diameter. So R is half of my diameter, which is really equal to 11. So I'm going to plug in 11. I'm going to square that. So pi R squared is my B, and then my height in this case is 10. So I'll multiply that by 10. When I simplify, I have pi times 11 squared is 121 times 10, which is going to give me 1,210 pi. And again, if I simplify that out with the numerical value of pi, that gives me 3,801.3 cubic meters. And that would be my final answer. Next, we're going to look at the volume of a cone. And a cone is kind of like a triangle that has a circular base, if you recall. And the formula for the volume of a cone is going to be 1/3 pi r squared h. So if you notice that pi r squared is coming from the circular base of that cone. The 1/3 is because it's kind of like taking up a third of the, maybe like a cylinder, if you want to think about it that way. And then the h is just the height. So let's go ahead and take a look at an example. For example 2, it says find the volume of each figure. So again, when I look at the volume here, I know that volume is equal to 1/3 pi r squared h. So when I just go in and I start plugging things in, I have 1/3 pi. My r value in this case is 3. We're going to square that, and then we're going to multiply it by the height, which in this image is 12. So this gives me 1/3 times pi times 9 times 12. I'm going to just go ahead and simplify. 1/3 of 12 is actually going to give me 4, and 4 times 9 is equal to 36. So this is going to give me 36 pi, and when I simplify that, this is going to simplify to 113.1 cubic meters. Likewise, for the second part, my volume is equal to 1/3 pi r squared h. So when I plug my numbers in, this gives me 1/3 pi times my r value. Remember, when I look at this, this is 18 is really my diameter, so that tells me r is half of that, or 9. So I have 9 squared times my height, which is 18. So now I have 1/3 pi times 81 times 18, and when I simplify this out, 1/3 of 18 is 6 times 81 will give me 486 pi, or numerically that's 1,526.8, and my units are cubic feet. The last shape that we're going to look at for volumes today is going to be what we call a sphere, which is kind of like a ball or something like that. And the volume for a sphere is 4/3 pi r cubed. Okay, so let's take a look at an example and see how this works. So for example 3, which is our final example for the day, remember that volume is equal to 4/3 pi r cubed. So when I start plugging things in, I have 4/3 pi times my r value, which in this case is 3.8, and we are going to cube that. So now what this leaves me with is if I take the 4/3 and I multiply it by the 3.8 cubed, I end up with 73.16 pi. And when I multiply all of that out, I end up with 229.75 cubic feet. And for my last part, I'm going to start with my volume is equal to 4/3 pi r cubed, and I'm going to plug in my r value. Well, in this case, 19.8 is my diameter. I need to plug in the radius, and the radius is really 9.9 kilometers. So I'll plug in 9.9, cube that, and if I simplify this, that gives me 1,293.7 pi. And when I multiply the pi out into that, I end up with 4,064.38 kilometers cubed. And that would be my final answer on that sphere that has a diameter instead of a radius. Please let me know if you have any questions. Otherwise, I will see you guys in class. Thanks.